Good morning, myself Dr. Prabhakar Rapaka, Associate Professor, Department of EC. My subject is Internet of Things. Today I am going to explain about the introduction to the Internet of Things and also related to the course objectives, course outcomes, syllabus coverage. So it is a professional elective one for the third year CAC. So it consists of 5 units. So first unit under module 1. So in module 1 we are going to cover introduction of IoT, definitions of IoT, architecture of IoT, key components like sensors, actuators, gateways, cloud platforms, along with their basic IoT standards and IoT levels. Coming to the unit 2, module 2, IoT communication protocols, introduction to the connectivity like MQTT, COAP, LoRa WANs, TCP, UDP, HTTP, IPv4, v6, NB, IoT, Zigbee, Wi-Fi, emphasis on their applications and differences. Unit 3, Module 3, components like sensors, actuators, embedded systems with the Raspberry Pis, data for data acquisition, programming Raspberry Pi, Python controlling LEDs, switches, interfaces, light sensors with the Raspberry Pis. Coming to the module 4, in unit 4, data management, data analytics, security, IoT data collection, cloud storage, cloud for IoT, data analytics, edge analytics, security measures such as authentication, encryption, and privacy. Module 5 in Unit 5, IoT applications like smart home applications, smart cities applications, smart agriculture applications, and retails, logistics, environmental, and industrial automations with the practical implementation examples. So your textbooks are Internet of Things and Sun Approach by Arshadip Bhagwan and Vijay Marri, University Press 2015. Next second textbook is Get Started with the Raspberry Pi, Meta Richardson's, and also references. So course overview. This course introduces the principles of IoT, covering the architecture, protocols, sensors, actuators, IoT, and embedded applications. It emphasizes the IoT design, connectivity, security, and real world across the industries. So for this, prerequisites are prior knowledge of embedded systems, basic knowledge on network concepts. So course objectives are the student can able to learn IoT architecture, IoT standards, ecosystem components, IoT communication protocols, connectivity options, sensors and actuators integration, IoT applications, data analytics, cloud platforms, security in IoTs, principles of IoTs and IoT applications, smart cities, smart agriculture, smart homes, and automation, industrial automations. Course outcomes are understand the characteristics, protocols, and prerequisites of the IoT design, realizing the hardware and components of the IoT systems. Next, different applications like machine to machine, person to person, vehicle to vehicle, like different industrial applications and consumer applications. Next, the history of this IoT is in 1990s, Kevin Stern coined the term Internet of Things. So almost it covers the every area every device, every sensor, software which are connected to the others. So that means according to the as shown, a total area covered with all the devices, all sensors, all gateways, all connected with the technologies. The ability to access these devices through the smartphones or through the computers. These devices are accessed from the distance. The evolution of IoT is in 1990s. Here, internet era developed. After it is wireless communication. Next, embedded systems. Next, cloud computing, artificial intelligence, Internet of Things. So this is the basic evolution of IoT. And technologies are enabled with the IoTs are sensors, RFIDs, Wi-Fi, cloud computing, big data and AI. Next, current status and future prospect of IoT. So here world population in 2003, 6.3 billions. Connected devices are 500 millions. Connected devices per person 0.8. In 2010, 6.8 billions of world population. Connected devices are 12.5. Connected devices per person 1.84. In 2015, world population is 7.2. Connected devices are 25 billions per person 3.47. In 2020 onwards, your world population is 7.5 billions. Connected devices are 50 billions. Connected devices per person are 6.58. Next, introduction of IoT. IoT is a network of physical objects enabled with the sensors, actuators, software, communication technologies, enabling them to connect the internet and exchange data automatically without direct human environment. These physical objectives such as devices, machines, systems like computer networks, which are used for enabling the real-time data collection, monitoring, and automated actions. So by using this, we can observe the improvement in the efficiency, accuracy in daily life and industrial applications. So see some of the examples here: smart homes, smart cities, healthcare, agriculture, and industrial applications. So here IoT is a combination of sensors, connectivity, user interface, data processing. There are 4 functions performed. These are the different components. Here also you can observe the difference between IoT and IIoT. Here IoT, you can observe Internet of Things. In IIoT, which are focused in the industries, they are called industrial IoTs. So in industrial IoTs, you can observe data collection, data analytics, automation, improve the operational efficiency and decision making. So see here, these are the consumer IoT devices like mobile phones, smart watches, smart TVs, like smart temperature sensors, Wi-Fi modules, and smart currents. We are observe robot arms, vehicles, right? Smart homes, smart vehicles, here smart Wi-Fi systems. So these are the industrial applications as well as the consumer IoT applications. You can observe. Next, observe the analogy between the human body and IoT. Here in human body, we can observe there are five sense organs, and here brain is act as a data storage device or like a CPU. So here our brain is like say process, and here eyes are data collection sensors. Here hands are observe the temperature sensors, and here ears are like microphones. Next here muscles are like energy storage devices, semiconductor materials. Next legs are like routers or paths for the networking. Next one is observe here the real-time experience of this IoT device. So here sensors are sensing the data. If you know the data, then reaction takes place here. Otherwise, without any data communication between the sensors and the data storage, there is no reaction. Next one is features of the IoT or connectivity between the person to person, vehicle to vehicle, or city to city, area to area. Next, intelligence. So you're based on the capturing here, data can be stored or processed. Next, automation. Next, real-time monitoring and data sharing. So next topic is IoT architectures. So IoT architecture, it contains the different four layers. One is perception layer. So under this perception layer, your sensors and devices are perceive the data. So these are used for the data collection. Second one is network layer. So this is used for the data transmission. Next to processing layer for cloud, and here this is used for the processing of the data. Next application layer. So here this is for the user services. So see here sensor layers are data gathering. Next to transportation layer or network layer, data transmission. Next for processing or middleware layers are process the information. Next application layer for the smart applications. Next one is the functions of these layers are discussed here. So in real time, the sensors are the temperature sensors, humidity sensors, pressure sensors, so are sensing the data and store the collecting the data. And here actuators are devices which are used to perform the logical signals into physical uh, outputs. Next, transport layers are transport the data uh, by using the devices to the gateways or edge nodes or cloud platforms. So by using the wireless technology like Wi-Fi, Bluetooth, Zigbee or cellular networks, and it supports the some communication protocols for the efficient and secure data exchange between the devices and systems. Next one is third one is processing or middleware layers. Here filter, analyze, store the income data and yeah, convert into the suitable format for the further use. So like this, decision making and manage the connected between the devices and handling the inter operationability and support the scalability across the IoT deployments. So ensures the data integrity, authentication, security access to the IoT devices. So next one is application layer. It provides the dashboards or mobile apps like web interfaces to the IoT for the monitoring and controlling of the IoT systems. Presents the processing data in the meaningful form to support the analysis and decision making. Deliver the domain specific solutions such as smart homes, so smart health monitoring systems to like smart agriculture and industrial applications, industrial automations. Next one is the components of IoT systems are there are different components you can observe industrial sensor devices, connectivity, cloud, user interface analytics. These are the components. Next one is here, observe the components like IoT sensors. So here sensors are collecting the data, and this collected data can be transmitted to the one system to the another system, or through the gateways. So here for that we are using sensors to collect the environmental data like temperature, motion, or light. Actuators are convert the digital signals into physical signals. Next, embedded systems, here microcontrollers, microprocessors, and all other devices we can join together, so that it is called embedded systems. Next, connectivity modules like Wi-Fi, Bluetooth, cellular systems. Next, IoT gateways are aggregate the data from the multiple devices and perform the protocol translations, secure transmission of the data to the cloud or edge platforms. So this cloud platform data can be analyzed in the IoT data, while edge computing process data near to the source and or reduce the latency. Next, user interfaces and applications. So in user interfaces, the dashboards, mobile apps, web interfaces for the monitoring the data, control the devices, and receive the alerts. So these are the components and functions of IoT. Like environment, here from the environment data collection by the sensors and actuators are convert these logical data into physical data, and microcontrollers are used for processing. Next, here internet of things, data management systems, communication interfacing, web applications, and also it is given to the some interfaces to the users like mobile service systems or computers. So here you can observe the different sensors are connecting the data and given to the clouds gateways, and also given to the cloud services, and also send the data to the mobile apps. So different types of sensors you can observe. So sensors are you are collecting the data from the environment. That is the main role of the sensor. So here different types of sensors like temperature sensor, image sensor, gyro sensor, obstacle sensor, RF sensors, and IR sensors. So different sensors are used for the collection of data in different forms. Next, gas sensors, LDR sensors, ultrasonic sensors also are there. So the major applications of these IoTs are like sensors, actuators, or microcontrollers, communication networks, gateways, cloud platforms, and user interfaces. So here different types of actuators you can observe, which are convert the electrical signals into physical signals. So they are like motors, relays, solenoids, and servo motors, hydraulic actuators. So examples for this are used for the smart doors and smart fan and smart irrigation systems. Here gateway functions you can observe. So data aggregations, protocol conversions, edge computing, and security systems. Next, cloud platform functions are data storage, analysis, analytics and dashboards, device management. Examples are AWS IoTs, Microsoft Azure IoTs, next Google Cloud IoTs. So IoT communication protocols are, you can observe here, in application layer, MQTT, COAP, HTTPs, AMQP are the application layer protocols. Next, network layer protocols are IPv6, UDP, TCP/IP protocols. In link layers, Wi-Fi, Zigbee, Bluetooth. Next to LoRaWANs and NFC are the protocols used for the IoT communication. Next, IoT communication protocols, you can observe the speed, here protocol, and speed, range, and power. So here Wi-Fi, here high speed, and medium range it can use it for the high power consumption. In Zigbee, low, medium, and low. In your Bluetooth, medium, short, and low. Your LoRaWAN, low, long, and very low. So IoT standards are, you can observe here, international standards like IEEE 802.15.4. So that is IPv6, 6CLO PAN, next to MQTT, next to CYAP, next to one M2M. Next one is importance of this one is interoperability, next to securability, reliability, and scalability. These are the IoT standards. Next, IoT levels are observed here. IoT level 1, single node, that is cloud. Next, IoT level 2, multi devices, gateways, and clouds. Next, IoT level 3, also device to device communication. IoT level 4 are edge computing. IoT level 5, cloud computing. Right. So next, advantage and challenge here, automation or remote monitoring. So better decision making. Next, cost reduction, energy efficiency. Challenges are security, privacy, and scalability, integrability, and power consumption. So IoT ecosystems are, you can observe here, the sensors are collecting the data via networks or edges, cloud systems where the data is processed and analyzed. So this is called IoT ecosystem. So yeah, IoT working based on the 4 functions. One is capturing, next one is communicating, next one is analysis and acting. Based on these 4 functions, IoT can be worked. Capture the data from the sensors, communicating with the network layer, analyzing the processor, and action takes place based on the works. So see here, the IoT working with the device. The working of the IoT device are involved the sensoring data, communicate with the networks, processing the information, and perform the actions based on the system requirements. Here client and server, you can observe. Here client initiates the SSH connections from the client to the server. Next, second one is indicate the acknowledgement to the server to the client. Next, third one is indicates the sending the public key. Next one is fourth one is encourage the check the authentications. Next fifth one is server sends the challenges. Next client sends the responses. Next one is server verify the signatures. So like this we have provided the security system between the server and the client. So data collection, data processing, data transmission. So these are the working of IoT devices by using the different protocols. So here first one is data collection and transmission. Data collected from the sensors and transmitted through the network layer. Next in the processing unit, data processing and trigger the generation. Next one is actuations based on the triggering. Next information reception from the client to the from the device to the device. Next one is communication between the device to the networks. That is done by using the MQTT, COAP, Zigbee, HTTP, and FTP, etc. Next one is communication between the device and networks are also done by using here MQTT, COAP, Zigbee, HTTP data. In our application layer protocols MQTT, that is our message queuing telemetry transport. It is one of the important application protocol. So here the lightweight and low overhead protocols are used in publishing subscribing models. So device and data to be broken, which distributes it to subscribers, making it ideal for the remote or low power IoT devices. So for that we are using these protocols. Next is COAP, constrainable application protocols, a simple web link protocol designed for the constraint the devices. It uses request or response message and can work over the UDPs, reducing the bandwidth usage and enabling the efficient communication for small sensors and actuators. Next, HTTP hypertext transfer protocols, a widely used web communication protocol. So connect the devices to the web server, so over the cloud platforms, allowing the easy integration with the web-based applications and dashboards. Next, transportation layer, TCP/IP protocols, transmission control protocols, which provide the reliable order delivery with the error checking. It ensures that the no data is lost and packets arrives in the correct sequence, which is essential for the application where accuracy is critical. Next, UDP, user datagram protocols. It is a faster and connectionless protocol, which is minimal overheads and is not guaranteed delivery, but it is suitable for the real-time applications like video streaming, sensor data, where speed is more important than the perfect reliability. So network support layers are IPv6 and 6LoWANs. So different applications like smart homes, smart cities, healthcare, wearable, industrial IoT, IoT, smart agriculture, transportation and logistic applications. So different machine-to-machine applications, industrial internet applications, industrial IoT applications. Next, smart cities applications. Next to vehicles, vehicle-to-vehicle connectivity, intranet of things. Next to web things. Next to embedded internets. Next to internet of everything. So these are the different industrial and non-industrial applications. So advantages, automation and efficiency, real-time monitoring, resource optimization, improve the decision making, and cost reduction. Disadvantages are security, where vulnerabilities, next to privacy concerns, next to reliability dependence, next to interoperability issues, some maintenance overheads. Thank you.